Well, we're currently traveling on an I-80 headed west, and wait until you see what I got to show you on this episode.
Just the finishing.
Okay.
All you're doing is taking, say, 7/1000ths off a side.
You know how we do it? You take the drill and you wallow it around, and you make that hole bigger, and then you put that bolt in there. I think it's pretty cool, and Lisa definitely thinks it's pretty cool. It's straight up guy stuff. Look at the car. Oh my God. I think most of that is actually from inside the campground. That's why we don't wash it before we tow. Okay, we made it to what's going to be our home base for Ohio. We're at a KOA. There's Lisa. She's got a walkie-talkie, so she's going to guide me back with the walkie-talkie. We got some low overhanging trees there. I'm a little worried about.
Looking good.
Well, we got up early and we drove into Cleveland, Ohio this morning. That's where the location is, where we're gonna go check out a machine shop, some giant machines. You excited?
I am excited.
So there you go. It's even exciting for girls and dogs. Okay, we're at Hahn Manufacturing. Pretty cool place. Been in the family for many years. They've been in business since the early 20s, I believe. They make giant parts. It's pretty cool. Come check it out. Okay, check this out. These giant blocks of steel, they get turned into this giant connecting rod.
So this is another one. This is a contour part. So this is it. This one's on its final stages right here. So you can see now this one's already has the bolts in it.
Oh yeah.
So it's been split, and he's doing the finish job right now, which is milling and then finish boring. That's a rod from a solid block of steel as well. Okay, so this one's almost finished. He just got to check for milling. So this one right here, this one just was turned in from a solid block to this. Wow. But there's still a lot to go. We got to rough the bores out, so we got to put the big holes in here, and then it goes out for MPI at that point. We'll check it for cracks. And then it comes back, and then there's a lot of work we do to it, and then we saw cut it. We'll cut the cap off, and then they do more work to it, and then we put it back together with the bolts in it. And then he has the finish out. So this one's close to going. This one's just starting.
Wow.
You're finishing them. They have to be like they're going to be used. So you can't finish them until everything is torqued the way it is going to be when it's used. Otherwise, if it's not tight enough or it's too tight, when they use it and tighten it to where it should be, you're not going to get the same sizes. That's how, everything's got to be like it's going to be used.
Now, you're saying that you have a torque wrench to fit that nut?
Yeah.
Okay.
Well, they actually don't call them torque. The way they actually specify the torque is they call it stretch. So, so if you look on the print, there's going to be a stretch dimension on that bolt. So they're going to say stretch that bolt, say 20/1000ths. So you will actually tighten it, and you have to mic it and tighten it until it stretches 20/1000ths. So if you look right here, you see that little dimple? That pin right there?
Yep.
There's one on the other side as well. We have what they call pin mics. And you tighten it, you check it, you tighten it some more, you check it, you tighten it some more, you check it. That's how.
So you're measuring the length between the tip there to the top of the bolt.
Yeah, and there's a spec on the print that tells you, 17 to 20/1000. That's how it starts out. This is kind of almost where it's going to end up at. I mean, this will all be bored out. These will be the same size as there'll be scallops cut in there because this has to be bored. If you look here, if you look at what we're going to be cutting out of it. Wow, look at that. So this is what they sent us. And this is what's getting cut out of it. This part right here. We need this to be straight because we actually use this when we do this operation, it's halfway from each side. So we'll do the first side and then flip it over and do the second side. You don't make it all from one side. You can't. So he'll use this corner to pick up, and when he flips it over, he uses the same corner to make his pickup again.
Okay.
And if it's all bumpy, you can't do that. I mean, they got to match. Otherwise, your seam won't, your halfway point won't look right.
Right.
It won't match. One side won't match the other. You can see it. You can see it on this one right here.
Look at the size of this one.
Right here, you can see that this is the halfway point. Right here.
Oh yeah, yeah.
So everything was machined on this up to this line, all the way around. And then we flip it over and do the same exact thing on the other side. Once again, this is one that's this is almost done as well. All that's left on this is finished milling. So there's 60,000 stock on this face, 60 on the opposite, and there's 60 in the boards. And that's it. That's all that's left on this part. These bolts are actually hydraulic tensioned. So they have a unit you put on them, and it's a hydraulic tensioner.
Right.
To make the stretch happen. That's something the customer supplies to us. So this one, the bolts will be stretched 5.5 thousandths. That's the torque they want.
5.5.
Yes.
Not 5, not 6, but 5.5.
Yeah.
Just the sheer size of this thing.
Not the biggest rod we've done, but some of the biggest bolts that we've done.
Now, did you make the bolts too?
We did not make the bolts. The bolts are supplied to us.
So somebody else is making
Somebody else makes
giant bolts.
Yes.
Just look at the sheer size of this thing. That is incredible. That's a giant connecting rod. They make giant parts here. Awesome. And that's out of a giant block of steel. This place is cool. And this is actually a rod bolt then.
Yes, it is. It's for that connecting rod behind you.
That's a small connecting rod. That's like Briggs and Stratton.
Yeah. When we're doing stretch ones, we can use this to tighten and loosen and check for stretch.
Is it air?
Yeah, it's air. Counterbalance, so you can move it around a little easier. Every customer does it a little different. These rods, the way they're torqued, is you torque it to a certain level, so they give you a foot-pound to torque it to, and then they say after you get to the torque, you got to rotate it another 45 degrees. So in the machining process, if we could get on there and look, you'll see 2 dimples on there. So you torque it, and then you put a little mark by the first dimple, and then we would use this thing, and it would turn it to the second dimple, and you'd stop.
And what do you use electric nitrogen for?
Bushings.
Oh, to shrink them down?
Shrink down bushings, yeah.
So now, when this thing works, you just build a certain amount of hydraulic pressure equals the right amount of tension?
Well, yeah, it's stretch. So this is the tensioning device, and this is actually a small cylinder right here.
Okay.
And it actually stretches like that, all right, and stretches the bolt. So the way it would work is, we'll say, tension it to 10,000 psi.
So you put 10,000 pounds of pressure into it.
Yes.
And
then snug up. Then you can get in here and you can snug up the bolt, the nut, and then you release that.
And it's preset at that point.
Yeah.
That's pretty neat.
He's gonna thread a stud into here.
Oh, okay.
And then it'll pull that stud. He'll tighten this down to where, when he gets the stretch he wants, is he'll snug this down, and then he takes the tension off, and then he'll take the stud out. So this is a little different configuration.
Then it's all set to whatever the manufacturer wants.
Yeah. And then we can finish machining.
Oh, that's the stud that threads into there.
That's the stud that threads in there, and then so this will be sitting here like this. So this threads into the end of that nut, and it'll come into here, and this is your piece with your threads in it.
Okay.
And then this is your hydraulic cylinder right here.
That's what does the expanding.
Yes. And it's obviously not there's not a lot of travel on that cylinder. We're only talking like a half-inch or a quarter-inch of travel, but you don't need that much.
No, you get it all snugged down, and you're just moving it to however many pounds.
Yeah, exactly.
You're moving it probably 20,000, 30,000 to the most. Look at the size of this socket. What size you need? Size of my hand. 4 1/4.
Something like this from start to finish. You're talking about machine time or actual chronological time? Chronological time, you're probably talking about 2 or 3 months from the time you first receive the material till it finally ships out.
For one connecting rod.
Yeah. And we're not working on it the whole time. Obviously, like this one's just sitting here right now.
Right.
So there's the way the process works. It has to go across one machine. Then you got to rip the bores out. Then it's got to go to MPI, and it comes back in. You got to do some finish machining on it. Then you got to cut it, and do some more machining. And then you got to assemble it and do some more machining. So there's a lot of times where it's not on a machine. So I say 3 months, but 200 hours, maybe 250 hours on this part of labor. If you want to look at man hours on it, we'll call them the MRI machine, but they're not. It's nuclear imaging, but those are those in production. And these are magnets right here.
So the whole thing just stays magnet. It holds it in place while that
Well, you can see
machine
that
cut it.
if you look at those riser blocks, you can see how all the chips are stuck to them.
Right.
Those are the magnetic poles.
Now this thing's loading in another tool. It just loaded in a tool.
Yeah. That whole head that's spinning right now can actually come out and puts a different one in, like a vertical. And then we also have one that's a BC head that rotates.
So the whole head could be changed too.
Yeah. So if you're looking at this right here, with this telescoping guard on it.
Right.
That's where the heads are stored. You can walk around back and out. You can't really see them because the windows are all dirty, but this has 3 different heads. That's the horizontal, the vertical, and the vertical.
Man, look how easy it just drills a hole in there.
That's a tap.
Oh, that's tap and thread?
That's tap and thread.
So it actually goes in at the rate of the thread pitch.
Yes. So you have like a half 13, you have 13 threads per inch. Okay? So when you tap a hole, the machine has to move at that 13 threads per inch.
It just blows me away that how big this machine is and how accurate that it is. It's so accurate.
Oh yeah.
How accurate is it? I mean, we're talking like what, 1,000ths?
No, less than that. Positional accuracy is probably plus or minus 0.0002. So 3 zeros and a 2. So it's 2/10,000ths of an inch, but we call that tenths. This is kind of the jargon that we use, right? You have your jargon, we have ours.
That is incredible. This machine is so large. We're talking this thing, to put it in perspective, this wouldn't fit in a 2-car garage. All right, behind me, the belt. That belt houses all the cutters and different drills, and this machine is programmed and it grabs whatever cutter it needs to continue and automatically loads and unloads it. Now how many tools does it hold?
That has 72. The one down the street has 120. All 3 of these machines are 62. And then those along that wall are all 50.
So they all have that same belt drive?
No, they're different. These have belts. It's a little different configuration, but the same idea.
Oh, it's getting another tool right now.
It's a Renishaw probe. And you can see the ruby tip on that. The tip itself doesn't really do anything. So this whole thing moves. So what happens, it'll move up and it'll touch the side. It deflects. See how it deflects?
Oh yeah.
And as soon as it deflects, it records that position. So you have motion this way, up and down, and then it also has in as well. That's how it knows where it's at. So you got the bore of that connecting rod, the pin bore. It goes through and it'll indicate that thing in and tell the machine where the center of that pin bore is, and stores that in what they call a work offset, and then everything's generated from that. So that's 0. Go down 30 some inches to the crank bore and bore the bore. But that's telling the machine where that hole is.
That's pretty cool.
This, if you look at this part, does it look familiar?
Yeah, that's the crankcase at the beginning.
That's a smaller crankcase,
Right.
Much smaller. And actually what we're doing with it, we scrapped that out years and years and years ago.
We
turned it into a honing machine. So this actually, if you look, this whole thing moves. And what we do with that is we hone parts, and honing is a way of putting a nicer finish on the board.
Right. Turned it into your own machine.
Turn it into our own machine. Hand-operated machine, but our own machine nonetheless.
Look at all the cranes in this place. So these 4 here are all the same?
All the same, yeah.
Wow. Oh, that one's actually doing something too.
You look in here, you can see what it's not right now. He's probing. That's just another.
One of those ruby things.
Yeah, you see the lights on it?
Yep.
Lighting up. That's actually checking some locations, and you can look at the results on the screen right there from the probing.
Okay.
You checking size right now?
I am.
Yeah, so he's checking the width to make sure the width is right. If it's not right though, he tweaks it a little bit so it comes out right.
This one here and then that one down there.
Yeah, and then that's the same style of machine, but it's bigger.
As these?
As these two.
Okay.
So a lot of the code that we run on these machines can run on that machine as well, with just some really minor tweaks to it.
But they can't run on these machines?
No.
Different manufacturers?
Yeah. These are American, actually. Haas, which is out in California, Oxnard, California.
Okay.
These are Toshiba, Japanese. That's Akuma, which is Japanese as well.
So that's a big chunk of granite?
Yes, it is. And he's checking a little connecting rod.
A little
So
connecting rod.
this is a forged connecting rod. So we didn't actually make the shape of the connecting rod. We received it that way, and then all we do is put, just to use layman's terms, we put the shiny surfaces on it. So you can see this right here. That's forging. We didn't machine that. That came to us this way. All this spot where it's gray. So what we did are the shiny surfaces. We put the bores in. We machined this. We cut the bolt faces.
That's probably the size rod that's in our RV.
What size engine you got?
8.3.
I bet that's a little big. Not much, but a little bit bigger. I bet you're talking.
Probably
What's the center line on the boards on those? 9? I bet you're talking like maybe 6, 7
You're probably
inch
right.
center line.
Yep.
So that's that connecting rod that he had on the plate over there.
On the granite table?
Yeah. So this is set up right now for finished board.
Okay.
Which is putting in, finishing these surfaces right here.
To where it's totally done,
Done.
that's it, ready for the
Yeah.
customer.
This is just another type of product we run. These are called Helen strainers. What those are actually they strain fluid, and where they would use them would be something like a nuclear power plant, where they're using the water for some lake or a river
Right.
to cool the reactors. So these things actually strain the water coming in, and they remove all the seaweed and fish and whatever else
Before
out
it
of
gets
them.
into the pump.
Exactly. You come over and look at this right here. The water would come in from the opposites. These are upside down right now.
Okay.
But the water would come in from the opposite side. There's strainer baskets in each one of these holes right here.
Okay.
And it would come through those strainer baskets and then out here, clean. And then the stuff that they wouldn't want comes out these, over here. Like you notice this one's not machined right here,
Right.
but this one is. So that filter basket's done.
Oh yeah, it's all drilled and tapped.
Yeah. So those two opposite ones are done. These two are not. That's the operation he's doing right now. He's putting these two on.
I guess you got one up in there, huh?
Yeah.
Wow, the control area.
Those boards. Kind of done.
We're actually inside one of the machines, and they've got one of the strainer housing things in there ready to be finished. This machine's large, and this is their medium-sized machine. Pretty incredible.
I was just saying, we make those in a bunch of different sizes. There are bigger ones and smaller ones. They also make them on a different material.
I just can't get over the size of this machine and how accurate it can machine. I figure the bigger it gets, the more play it's got in like bushings and bearings, and this thing is just enormous. So what do you think, Lisa?
I'm impressed.
She's gonna change her career
She can be a machine operator.
and enjoy all this glamour and luxury now. These are tools that are set up like these are taps. He's put threads in.
Oh, that's different. A little different than the tap that I would use. That these are cut on a spiral.
There's different kinds. There's spiral. That's called a spiral flute, and there's spiral point. So this is spiral point. This is straight,
Right. Okay.
but there's this notch cut in the tip here. It pushes the chips forward.
Right.
That's called spiral point.
That's kind of like the taps that I have. You know, just the small stuff.
These are straight flute as well.
Okay.
Spiral point they call that, but they're straight flute. These are high use tools you use on different jobs. Like so, you know, you have like this size tap. He'll he'll use it on multiple jobs, so he just stores it over here when it's not being used, and then when a job comes up and he has to come get it, he knows everything's all, some of the stuff's just preset stuff, not dedicated to a specific job, but just preset for a job.
So not all the same tooling sits in the machine for every job?
No.
You have to load in what you need?
Yes, you have to load in what you need for the job, for sure. These are gun drills. These are what drill those oil holes through those, you're asking about the lubrication holes in those rods. They're called gun drills. They're single point, single flute. There's one cutting edge on them. So there's only one cutting edge. It's not like your standard drill. So this is your cutting edge. This slot down here is how the chips evacuate out the hole.
Oh, okay, yeah, because you're so deep into
it. And you have to have coolant through it. So you have
through the middle of the bit.
Through the middle to push. It's for cooling. And it's also for evacuating the chips out of the hole. Chip evacuation is important. If the chips stop coming out, then that's when the tool breaks. This is an insert drill.
It looks like it's got replaceable carbide tips or something.
Most of our drills do. We don't do a whole lot of high speed, what they call high speed drilling anymore. We still have them, but yeah, these are inserted drills. This is another version of an inserted drill. So this is more like what you would see as a standard twist drill, like maybe you'd see at Home Depot, but this is also inserted. So if you're looking at the very tip right here, that's carbide. Just this little piece right here is carbide. And this actually twists off and you can put a new piece on when it wears out. So you have these two are both cam drills. That's the style they call it. So you got that twist on Kyle insert. This is a do-on. This has two inserts that sit on the face.
Oh, okay.
Like something like this, if you use a high-speed drill, you know what a high-speed drill is, right?
Right.
It's your standard type drill. We don't like I said, we don't use them a whole lot because they're slow. But
the high speed is considered slow?
Oh, it's super slow compared to these inserted drills, yeah. So something like this, you're running at like 20 inches a minute. A high-speed drill, something this size, maybe an inch and a half a minute.
You can run like this right here. This is what? Is this inch and a quarter, inch and a half?
687.
So you're talking this thing can do 20 inches in a minute through steel. Wow.
Yeah, the chips are flying out of there. And that's why the coolant's important to keep those chips coming out of that hole.
Right.
So that's what these holes are on the tip. Those are coolant holes. Here we are. This is high-speed drill. We don't use a whole lot of high-speed drills. We don't.
Because they're too slow.
Too slow, yeah. Like all this tooling in here is all dedicated.
Oh, per job, the repeat jobs.
Repeat jobs, yes.
Now, David, what are these things?
Those are boring bars. That's what you would do, like fine finishing on a hole. Like if you need to make a 3-inch diameter hole and it has to be super precise, that's the tool you would use.
Okay.
That is one of the tools you would use. These are different versions. Like so, this is a smaller hole. So this would bore a say 1 1/4 inch diameter. And the way that works is, so it's got a single cutting edge on it, and this thing actually slides this way on here, and that's how you adjust the size. So you go in there, so you see on here there's a dial.
Oh, okay.
And you can actually twist this dial, and this whole thing moves towards you.
So you drill the hole, and then you can move it out a little bit more, and it makes the hole a little bit bigger?
It won't drill a hole. There has to be a hole there already.
A hole there already. This is just to make the hole bigger.
That's a finishing. No, this is just a finishing tool.
Okay.
All you're doing is taking, say, 0.007 off a side.
You know how we do it? You take the drill and you wallow it around, and you make that hole bigger, and then you put that bolt in there. So and get back on the road.
Okay, this is set at 575 right now, inch 575.
Okay, so you drill the hole, and the machine knows exactly where the center line is.
Yeah.
So it comes out, changes bits, goes right back to that same center line, and then that thing's off center just a little bit to make the hole a little bit bigger.
And then you can check size on it. If it's not right size, you can adjust it a little bit more off center, or a little bit less off center to make the right size.
Sounds like to me there's a whole lot of places that something could go wrong on a gigantic connecting rod.
Well, there is.
Like
there's a ton of places something that I think I said that down there. Lots of places where stuff can go wrong. Everything's got to go just right.
Well, we had a pretty good time at the machine shop. Hope you guys enjoyed that. What'd you think of it, Lisa?
Oh, it's amazing.
Now, you can't just stop there and go, hey, we're here to see a tour of this place. It doesn't work that way. You might be asking yourself, who goes on vacation and goes to a machine shop and does a tour? Well, we do. So, a little bit different. We try to keep it, just interesting. So, you may not see the standard run-of-the-mill like when we went to St. Louis. We didn't do the arch. We did other things than the arch. So, just a little bit different. Plus, we got our dogs. So, we got to, accommodate them also. I just wanted to take a moment to thank Laura, David, Bobby, and Greg. Appreciate you guys taking the time out of your schedule to accommodate us. and give us the tour. We really appreciate that. So hope to see you guys again next year. And for all the subscribers, I wanted to thank you for subscribing and following us along on our adventures. And I hope you stick around for the next video. We don't even know where we're going yet, but we'll get it figured out. So, all right, till next time. See ya.